Welcome. Today we'll solve a challenging implicit differentiation problem involving trigonometric functions and natural logarithms. Let's start with our given equation. We have secant of x raised to the y power equals tangent of y raised to the x power. Our goal is to find dy dx. The first step is to take the natural logarithm of both sides. This will help us deal with the exponents. Remember, when we take the natural log of both sides of an equation, the equation remains equal. Next, we can use the logarithm property that states log of a power equals the power times the log. So, y times ln of secant x equals x times ln of tangent y. Now comes the tricky part. We need to differentiate both sides with respect to x. Remember, y is a function of x, so we'll need to use the product rule and chain rule. On the left side, we use the product rule. The first term is y times the derivative of ln secant x, which is tangent x divided by secant x times secant x, plus ln secant x times dy dx. On the right side, we get x times the derivative of ln tangent y, with respect to x, which involves the chain rule, plus ln tangent y. Let's simplify the left side. The secant x terms cancel out, giving us y tangent x plus ln secant x times dy dx. Now let's group all terms with dy dx on the left side and all other terms on the right side. We get ln secant x minus x cotangent y secant squared, y times dy dx equals ln tangent y minus y tangent x. Finally, we can solve for dy dx. We divide both sides by the coefficient of dy dx to get our final answer. And there we have it. We've found dy dx through careful application of logarithm properties, the product rule, and the chain rule. This is a great example of how implicit differentiation can help us find derivatives of complex relationships between variables.